Welcome, this is the start of C4. Really getting into the thick of A2 maths now. The first topic in C4 is partial fractions. In this video, the only things I'm going to be showing you is what a partial fraction is, what it looks like in terms of the constants, and how to calculate the two constants when it's split up into two partial fractions. There can be two or three, but I'm only going to show you how to calculate the ones with two constants in it, and I'll show you a bit more what I mean by that. So I'll just demonstrate that now. So say we've got an equation that looks something like this. So 3x over brackets 2x take 1 x plus 2, and it says show that as a partial fraction. Well, first of all we need to know what partial fraction looks like. So it's going to equal the same thing. We're not dividing it by anything, we're not doing anything, it's going to equal exactly the same on either side. So what you notice here is we've got two factors, and the key thing is they're two linear factors. They're not squared. It's not 2x take 1 squared plus times by x plus 2. It's just simply 2x take 1 times x plus 2. Okay, so how do we split this up? Well, we go from left to right in terms of the factors. So each linear factor, because what this is essentially saying is 3x over 2x plus 1 plus 3x over x plus 2. So we can split it up, but we don't know what's over 2x take 1 and we don't know what's over x plus 2, because to add them together that will equal 3x. So something over 2x take 1, plus something over x take 2, and that equals 3x over 2x take 1 x plus 2. So generally the first linear factor goes first, so it's a, let's call that first constant a, 2x take 1 plus b over x plus 2. Okay, so that'd be your two linear factors. Now the other one I'm not going to go into. I'm going to show you what it looks like, but I'm not actually going to go into too much detail about it yet. Is you might get one that looks like this. So use the same 3x, except in this time it's going to be 2x take 1 squared times x plus 2 on the bottom. Okay, so what we've got now is we've not got two linear factors. We've got one quadratic factor and one linear factor. Okay, so what is 2x take 1 squared? Well, if we, without expanding it, what it actually looks like. Factorise. Damn it. Well, scared the pants off me, that. What it actually looks like, 2x take 1 is squared, is 2x take 1 bracket 2x take 1. It's just itself squared. Okay, so that could be 3 squared, and you could just write down instead of that. That's what we're saying, but instead we're saying some constant. So we could rewrite, that 3x over 2x take 1 squared times by 2x as this. So we could do that. So we've got 2x take 1, and that's the same to open two brackets. So we could have that all over 3x. Now these two fractions here, they mean exactly the same thing, but that is just a shortened version of that, because it would be quite a mouthful to write all that. And for some, you might have to the power of 5, and that's going to take quite a long time. So what we do instead, if we want to split this up into a partial fraction, we do the same theory here, but this time instead of 2, we've got 3. That's because one of them is to a power squared, so we write it twice. And now we're going to have obviously 3 constants. So it's going to be a over the first constant, over the first linear factor, which is 2x take 1. Because that's squared, we imagine it's there twice, plus b. And because it's there twice, we've got to write 2 constants in with the same bottom, 2x take 1, plus c over the final linear factor, which is x plus 2. And you have to ask yourself, you say, well, what happens when I add, what happens when I add fractions? What has to be on the bottom? Well, the same denominator must be, it must be the same denominator, sorry, I almost said it must be the same denominator on the bottom, for sake, isn't it? Obviously to add them, because you can't really, in your head, you can't add 3/9 and 4/5 without putting it in your calculator, which your calculator skips a step before you can see it's working away in the background. It makes them both the same denominator. so you can add them or take them, etc. So this is what we're going to do here, okay? Obviously not in this one because we're not up to that yet. We need to show you what the first one is going to look like. So that's how that one would look if you had 2x squared, and that's why we've got 3 factors, because essentially what we'd have is three linear factors on the bottom. But we're going to focus more on solving this one first. So hopefully you get the idea of one with 3 factors on the bottom. Essentially that's what it is. They call it quadratic factors, or whatever rubbish mathematicians call it. So what we're going to do is we're going to focus on this one actually, because we've already started this one and we've explained how it would look if that was squared and how it would look if it was a linear factor. So what we're going to do is we're going to try and work out what a and b are, okay? So as I said before, so if we write out this 3x over 2x take 1, x plus 2. Now what we said before was we said this is going to equal a over 2x take 1 plus b over x plus 2. Now we said before we need to add fractions, but we need to make sure they have the same denominator, and clearly them two don't. So what do we do then? Okay, so we do what we normally do if we were adding normal algebraic fractions like we did in C3. So what we do is we times, because we need to times them both by 1, otherwise it'd be changing the fraction. It wouldn't be no longer equal to 3x over 2x take 1 x plus 2. So what we need to do is we need to give them the same denominator, okay? So what we could do, what we do in our heads essentially, is times them. So we times them both by the factor it's not got on the bottom, but essentially what we're doing is we're timesing them by 2x take 1 x plus 2, so it's a times 2x take 1 x plus 2, so I'm going to write it in full. So if I give myself a bit of space here and write b a bit further over, you don't need to do this because all you need to really do is write one factor, and I'll explain why. So if we make that bit wider, so it's a times 2x take 1 x plus 2 over x plus 2. Sorry, so it's gonna, so b, and then that is over x plus 2, and it's b, same thing, 2x take 1 over x plus 2. So we make sure that times them by the same denominator, okay? So what we've got here is we've got a times 2x take 1 x plus 2, and then that's over 2x take 1. And now obviously the 2x take 1's here, they both cancel out. So what we're left with here, so we write underneath, is a times x plus 2. And if we do the same here, the x plus 2's cancel. So if we can imagine them without there, just because essentially what it is times by 1, and we can ignore that. b times 2x plus take 1. And this is still equal to the same thing on this side. We haven't done anything to this side. All we've done is times this side by 1. And so we could just put 1 here, but we don't need to. So that's 2x take 1, bracket x plus 2. So that's what that looks like so far, okay? So then how do we work out what a and b are? Okay, it's very good we've got it in this format. It might actually ask you to have it in that format. But then it might ask you, well, what is actually a and b? Because the two constants here of a and b are the same as the two constants at the top. Because all we've done is simplified it, essentially. One sec, let me make sure you can still see that in the camera. Maybe a sec. Yeah, sorry if you can't see it on the camera, it's not brilliant. I should have the light behind me, really, it's a bit to the side. So anyway, obviously I can't change the light fit in at the moment. So what would we do then? Okay, well our next step is to say, right, okay, what would make this 0? What would make that 0? It's sort of like a quadratic equation, essentially. So, because obviously one of these is going to equal that. So the first one we go, well, what makes a 0 here, okay? Sorry, I keep rubbing it out by accident. So if x was minus 2, a times minus 2 plus 2 would be 0. So if we put minus 2 in here, so obviously that's going to equal 0, so we don't need to write that, we could put 0 plus, sorry, if I put x equals to minus 2, a equals 0, b, so if we put b in, so b times 2 times minus 2 minus 4, so it would be minus 4 take 1 times b, and if I'm not going to write another step, I'll just rub that out. It would be b times minus 5, so it would be take 5b. So you can write that in again. And then what we do is we put that the other side in as well. So let me double check. Because obviously we've got rid of the denominator on this side, so that just becomes 3x. Okay. And if x is minus 2, we put 3 times minus 2, so that becomes, sorry, keep it on this side. That becomes 3 times minus 2 minus 6 equals minus 5b. And if we swap them around so they both become positive, or times them both by minus 1, that becomes 5b equals 6. Therefore b equals 6 over 5. And that gets you your answer, which I think is 1.2, is it? Unless I'm being absolutely mad. Yep, so that's b, okay? So that's very good, that's what b is. So b up here is that b there, because we said that the constants are the same. Alright, so what we did to get this is we times both of them by this factor. So we're timesing this side by 2x take 1 x plus 2, so that gets rid of the denominator on the bottom, so that's why here we've just got 3x. And then we times this side by these two as well. So we times a by 2x take 1 x plus 2, but the 2x take 1's cancel. And then we times b by 2x take 1 x plus 2, and the x plus 2's cancel, so we get to this. Okay? So that tells us a times x plus 2 plus b times 2x take 1 is equal to 3x, because the denominators cancel. So we could almost rub that out there, if we could imagine ourselves getting that far, in terms of, you know, keeping with it, because I lost it on the first time. And then 3x equals minus 5b, and we put in x was 2, so we need to put x plus is minus 2, sorry, on this side as well. That goes minus 6. We simplified it to get b, that gives your answer. But that's just b, we want a as well. Now what we could do, we're going to do the same on the left hand side, so the same we did for b to get a to get b, and b to get a. So what we did there is we made a 0. This time we're going to make b 0 to get a. So it's like the opposite. It was like finding x and y to get actually putting y 0. Okay, so it's the same sort of thing. So then we make b equal to 0. So we're still going with this tantalising equation here. So then what would make b 0? Okay, so 2x take 1 equals 0. So what would x be? Well, obviously we need 2x to equal minus 1. Is it right? No, yeah, 2x to equal 1, sorry. Yeah, because you switch it across. So you could rewrite, if you were unsure, you put 2x take 1 equals 0. So therefore 2x equals 1. Therefore x equals 1 over 2, or x equals 0.5 or a half. Okay? So that we put x is a half back into the equation, so that was just demonstrating how we got x is a half. But obviously that's not the answer for a, because we want a. So we put in x is a half, because that would get rid of b. So if that gets rid of b, so 3x equals, if we put a half in here, so 2 and a half, so that's 5 over 2, so 5 over 2a. 3x equals 5 over 2 times a, or you could put, simplify this down, so you put 6x equals 5a. So x equals, so if we know what x is, sorry, in this instance, x equals a half, so 3 equals 5a. Therefore, 3 over 5 equals a, which is 0.6. Okay, so they're your two answers. And then what you'd simply do then is, you know what b and a is, you just rewrite them in. So we could just change this. Obviously you'd write it on a new sheet, but b would be 6 over 5 and a would be 3 over 5. And you could put that in there and that would work for any value of x. You could double check it by putting your numbers back in. So hopefully that sort of explains it. Okay, so I'll just give you a minute to just work through that in your mind. And then I'll explain the formula again so you can write down the method. And hopefully we can apply this to future questions in C4. The next topic obviously is going to be doing this with three coefficients, A, B and C, as we demonstrated halfway through this video. But as I said, I'll just give you a minute just to go through that in your mind. I'll shut up for a minute. Just give me a minute to pause it. Well, a minute's a bit long, but you know. Okay, hopefully you pause it and I don't think about that. So essentially the method is you, first of all, if you don't know what the linear factors would look like, it's A over the first linear factor, so in this case it's 2x equals 1, and then B, or whatever other letter you want, over x plus 2, the second linear factor. Then you rewrite that out with A and B in there, obviously if you hadn't done already. And then the denominator, so you times A by the two linear factors and one of them should cancel, and you times B by the two linear factors and one of them should cancel. Then you simplify them down, so the original equation, it should get rid of the denominators because you've times both sides by them denominators, hence getting rid of them two denominators under what is the 3x there. And then what you do is you go, okay, one of them needs to be 0. So just like quadratic sort of thing. So you go, oh, okay, we'll put what makes A or B 0. And you put the corresponding x or x value in. So for A, it was something plus 2 equals 0. So x was obviously minus 2 in that case. We put x is minus 2 into the whole equation, so both sides. Simplified it down, obviously A got 0, so you put A times 0 or just 0, if your mind works that way. Simplified it down, you got B, we got it as 6 over 5, 1.2. We did the same for the other side, so B, what would make B 0, so we could get A on its own, and it turned out x was a half, so then we put that into both sides of the equation, simplified it, got A, and then what you do then is you got B and A, so you just rewrite the fraction as changing the original fraction, A and B, to the corresponding A or B values that you found. And that is your partial equation all sorted there, done for you. Okay, so hopefully that provides some kind of insight into partial fraction. This is the first video of C4. Hopefully it's been of some use. We'll see you in the next video, and hopefully you're enjoying the course so far. So don't forget to like and subscribe. Cheers.